Hello and welcome to the online session of Apparel Made-ups and Home Furnishing। जॉब रोल है स्पेशलाइज स्विंग मशीन ऑपरेटर। इसका लेवल थर्ड है जिसका यूनिट 6 पर्सनल हाइजीन एंड क्लीनिंग एंड मेंटेनेंस एट वर्क प्लेस। Here we are going to learn cleaning and maintenance at workplace। Session objective है in this session students will learn what is maintenance, students will learn about types of maintenance at workplace and also different steps involved in maintenance।
Strategies could be improved in this company. Also, like every company, this company wants to take advantage of low labor costs and good export policies. So, therefore, it is important to keep production running 24/7, and that is only possible if equipments and machines are at their best and maintained. But at the moment, company's current maintenance management system is not contributing as it should be and must be improved in order to meet company's objectives and goals. So before we try to develop an improved maintenance plan, we need to know what maintenance actually is and how much significant it is for any company. Production systems in which maintenance is not given proper attention would always give you defective products. And if your company's vision is to expand in future, it is impossible because until a company does not include maintenance into its top priorities, it would always fail in achieving quality and production goals. Just because these guys from maintenance department are not utilized properly, we have oil stains in this t-shirt and this one has skipped and broken stitches, while in this picture we have an unsecured seam at sleeve hem. So it is very important to have an effective maintenance strategy to produce defect-free products. But almost all the companies run away from maintenance because it is very costly. But you cannot run away from it because if your company won't even exist in near future. Maintenance strategies can be divided into two groups, namely planned and unplanned maintenance. Unplanned maintenance activities are generally restricted to correcting an emergency to prevent injury or loss, while here you can see planned maintenance is further divided into other branches like preventive maintenance, condition-based maintenance, reliability-centered maintenance, predictive maintenance, and corrective maintenance. Preventive maintenance is the utilization of planned and coordinated inspections, adjustments, repairs, and replacements in maintaining an equipment or plant. One of the main objectives is to detect any condition that may cause machine failures. So this strategy completely revolves around prevention. So the next strategy that we have is predictive maintenance. Predictive maintenance involves the prediction of the failure before it occurs. The main objective is to predict an impending failure well in time, thus avoiding failures which could cause heavy penalty costs and even safety hazards. Then we have condition-based maintenance. CBM is a maintenance strategy carried out in response to a significant deterioration in a system or a unit as indicated by a change in a monitored parameter of the equipment or system based on its condition or performance. So here you see another way to describe maintenance management strategies. When we fix an equipment on urgent basis, it's reactive, but if it already was scheduled, then it comes under periodic maintenance. While proactive maintenance is used when we want to eliminate defects at an early stage. And finally, it's predictive if we use analytics to predict machine failure. Reactive is failure based and it is too late, and we use it in case of emergency or for the least critical item. Preventive, it is age based. We can say it is too early, and we use it for very critical machinery or equipment that plays the most important role in operations. At last, we have predictive, it is right on time. We use it when maintenance is too costly and the equipment or machinery is also critical at the same time. So you can see how reactive maintenance allows assets to run to failure, while preventive maintenance aims to prevent failures before they occur, and predictive maintenance predicts problems to increase asset reliability. Here we have total productive maintenance, which is called TPM. In many industries, total productive maintenance is a system which is used to maintain and improve the integrity of production systems and quality through the involvement of everyone in caring for machines and equipment. TPM as a strategy avoids sudden breakdowns and helps in effective maintenance, which minimizes unplanned or emergent breakdowns. In the textile industry, TPM is used in assignments like machine inspection, cleaning, lubrication, needle replacement, and basic machine setting tasks by the machine operators. The key measurement of TPM is machine effectiveness, which includes availability, performance efficiency, and overall equipment effectiveness. TPM is mainly accomplished through 7 pillars which help to ensure zero defects, zero breakdowns, zero waste, and zero accidents with total employee participation. One of the 7 pillars of TPM is focused improvement. In this pillar, cross-functional teams are assembled with the main aim of working on problematic equipment and coming up with improvement suggestions. The use of cross-functional teams is important to have a large and varied number of employees involved to bring in different experience or views. Then we have autonomous maintenance. It places the responsibility of basic maintenance activity in the hands of operators and leaves the maintenance staff with more time to attend to more complex maintenance tasks. The third pillar of TPM is planned maintenance. It schedules maintenance activities based on observed behavior of machines, such as failure rates and breakdowns. By scheduling these activities, the cycle of breakdowns and failure is broken, thus contributing to a longer service life of machines. Fourth pillar of TPM is training and education. This pillar is concerned with filling the knowledge gap that exists in an organization when it comes to TPM. Ensuring that employees are trained gives the organization a reliable pool of knowledgeable staff that can drive the initiative competently. Fifth pillar of TPM is quality maintenance. This ensures that equipment can detect and prevent errors during production. By detecting errors, processes become reliable enough to produce the right specification the first time. There is another pillar called early equipment management. It uses the experience gathered from previous maintenance improvement activities to ensure that new machinery reaches its optimal performance much early than usual. The final pillar of TPM is safety, health, and environment. This pillar of TPM ensures that all workers are provided with an environment that is safe and that all conditions that are harmful to their well-being are eliminated. As we have successfully discussed various strategies, now we will be discussing the right methodology to assess the current maintenance system. The initial status of the maintenance system was assessed in order to identify the problems that were experienced regarding maintenance management. This included interviews with the maintenance manager as well as document analysis to triangulate information obtained from interview with maintenance manager. Then a root cause analysis was carried out to understand the contributing factors to system failures so that actions could be developed. So this is an actual root cause analysis and all the defects are mentioned in specified category. For example, the machine is not working properly because maybe it is old, or maybe the incorrect machine setup is being used, or needle being used are dull, or lastly, maybe the machine is completely defective. So these are some of the causes in machine category due to which we are not getting right quality in products. Similarly, there are other causes too. In category of manpower, method, and material. Our purpose is to study them all and decide which of these causes is the main problem. Once we identify that actual root cause, we eliminate it, and that's how our quality will be improved.
Results and discussion. While assessing the current maintenance system, it was found that the maintenance manager is randomly called by the machine operator to repair the damaged machines. In addition, there were no records of maintenance carried out on machines such as maintenance log and preventive maintenance log. Upon assessment of the current maintenance system, it was found out that the problems at the textile company included the following. One of the problems at the textile company was frequent machine breakdowns. They were caused by the lack of history of machine failure since there was no maintenance log. Furthermore, there is no root cause analysis to determine the cause of machine failure. Another problem was unreliable machines in production. The company did not have preventive logs, hence the reliability of machines was unknown, and there was more downtime because machines randomly failed. Another problem was limited tools and equipment spares. Machine spares and tools were limited, and this caused the machine to idle, in case where the machine had breakdowns and waiting for parts to be replaced. This problem was due to lack of strategy to order the machine parts that are used frequently. One of the problems at the textile company was the lack of knowledge about autonomous maintenance of machines, as most operators in the workshop demonstrated limited knowledge on autonomous machine maintenance, which keeps machine operational. Now moving further, we'll discuss the common types of machine failure and causes of failure diagnosed through the root cause analysis. After analyzing the types of failure and their causes, a detailed investigation on root causes was performed. One type of failure is needle damage. That includes needle breakage and bent needle. Causes of failure. Number 1. Using the wrong size needle. Number 2. A bent needle which results in low quality of products and ultimately needle breakage. Number 3. Needle may be in loosely. Top tension is too tight or thread is wrapped around something.
There are three other types of failures too, which include looper damages, upper thread breakage, lower thread breaks. As you can see, this is our looper. When a needle is bent and repeatedly hits the looper, it may break or bend it. Also, incorrect winding of threads onto the bobbin damages the looper. Excessive tension to the bobbin threads, incorrect fitting of bobbin case also damages the looper. Or maybe upper tension is too tight, thread may be wrapped around spool holder or thread guides or caught on spool thread slot. One of the most common type of failures experienced and observed in the machine is the upper thread breakage, and there are various reasons why this happens. One of it is wrong threading of the machine, poor quality of thread, irregular tension. These were some of the reasons why upper thread breaks. If we discuss why lower thread breaks, it also has few reasons. If we discuss, one of the main is wrong threading of the machine, poor quality of thread, irregular tension, inferior thread or mismatched thread. Bobbin case is too tight, needle plate hole has sharp edges or shuttle has rough spot.
Now we'll discuss the suggested solutions for major defects with corresponding causes. The first area of defects is man. Causes: carelessness. Solution: improve supervision. Cause: inadequate training and operator inefficiency. Solution: train operators sufficiently about autonomous maintenance. Another area is the machine. Cause: machine is threaded incorrectly or excessive thread tension. Solution: rethread machine and maintain proper thread tension. Make sure the thread passes through the tension discs. Cause: dull or bent sewing machine needle and knife. Solution: replace the needle and knife with a new one. Cause: old and defective machine. Solution: replace with new machines and ensure preventive maintenance. Cause: excessive pressure on the pressure foot. Solution: lessen the pressure on the pressure foot, slacken both tensions. Another area of defects is the method. Cause: incorrect size of the needle and thread for operation. Solution: the size of the needle and thread should be synchronized. Ensure both the needle and bottom looper positions are rightly fed by the correct thread type and size. Cause: incorrectly inserted needle. Solution: insert the needle on correct position. Check that the bobbin is wounded correctly and no loose threads or loops sticking out. Cause: comparatively long stitch for the type of fabric and work. Solution: Shorten the stitch length by means of stitch regulator, especially when sewing fine fabric. Another area of defects is material. Cause: poor quality thread. Solution: use good quality thread. Cause: poor quality needle. Solution: use high quality needle from another brand. Needle should have high heat and wear resistance capacity. Cause: limited spare parts. Solution: develop an inventory control system for ordering spare parts. Cause: improper finishing. Solution: to cut thread properly, start regular checking system to check the machine is properly functioning or not. Also to improve quality inspection system. Now we'll discuss the maintenance objectives. Effectiveness of maintenance is measured by the ability of the policy to achieve the desired outcomes regarding maintenance in the organization. The following are the objectives of the maintenance policy developed for the case study of the company. Number 1. To keep the maintenance cost per production item produced as low as possible. Number 2. To keep the quality of the product very high. Number 3. To keep the downtime for critical equipment as low as possible. Number 4. To keep maintenance cost as low as possible. Number 5. To provide effective and trained personnel.
Metal control procedures. Since the organization uses a lot of sharp objects in their production processes, there was a need to develop a metal control procedures under the maintenance policy. These procedures were designed to cover all the actions that must be carried out when handling sharp objects in different tasks. Saving and knitting needle control. This is the major concern of every garment factory, deals with the critical factors like sieving, knitting and needle control. So here comes the first one. Needle control policy covers the strict control of all needles to ensure that only one is used are for the manufacturing process, and that is disposal of all the worn or broken needle is carried out by the authorized person. In order to control over the needle wastages, and they have a strict policy. Secondly, the only needles allowed at workstations are those currently needed to operate the machine process. No spare needles should be held at machine point. Therefore, no needles are kept in a locked location, only to be accessed by a trained or authorized person. The next is worn and damaged needle replacement. It's also a strict policy that needles which are worn or damaged but not broken are to be collected, and a new needle must be issued by the authorized person only. All needles are need to be disposed of into a sealed jar or tin with a small opening in the top. The jars The jar must be kept in the secure location and disposed of responsibly. The next policy for needle replacement and procedures. When a needle breaks, the operation must be stopped and the maintenance supervisor be informed. All the needle pieces must be located and checked against a whole needle to make sure all pieces have been found. The pieces must be immediately attached to the record sheet with clear adhesive tape and fully recorded with all information. A new needle may only be issued when it is confirmed that all the needle pieces are found. If all needle pieces cannot be found, then the product being worked on and any other work gear must be placed into a bag or a box and taken to an isolation center for further checking. The workplace must be checked with a hand-led metal detector or a magnet before work restarts. The handheld detector must be calibrated and operating correctly using the 1.2 mm test piece before being used. Check for the missing needle pieces in the isolation center. If found, all the pieces are to be recorded on the record sheet as a normal. The next one, blades and knives. This is a procedure how the blades and knives being replaced or changed on. Knives, blade, scissors and snips can be used in every area of the factory for cutting room to the warehouse. All new and used cutting blades for bent knives and straight knives must be kept in a locked cupboard with access only by the cutting room maintenance supervisor. Record must be kept of a new blade in stock, issued blade and returned blade so that every blade is accounted for. The instructions should be considered pertaining to the sharp objects in the workshop. Under no circumstances can all blade be turned into the knives for use in the production area. All blade must be disposed of responsibility on a regular basis. Where knives are need to be open container, there should have a retractable blade be numbered and stored at the end of each day in a secure cupboard. Small scissors and snips must be tied to workstations, and this applies to all areas used for cutting, sieving, inspection, pressing and warehouse. Large scissors in the cutting room and sample room are to be numbered and stored in the secure cupboard at the end of each working day. The supervisor responsible for scissors must check all have been returned to ensure that they are not lost or stolen. Proper care must be ensured when operators are holding sharp tools. They must be held with the blade pointing downwards to avoid injuring one another. More than that, the next is maintenance activities should be continuously updated. Duties of the maintenance manager could include at least the following: inspecting the facility, checking electrical units of machine, ordering parts and equipment, recording daily maintenance activity and preparing work schedules. Making machine operator should record a maintenance checklist before using any machine. The proposed maintenance strategy for the organization is preventive maintenance. The best way to maintenance activities is to bring breakdowns to the preventive maintenance. So each property will have a preventive maintenance schedule that will be completed by the maintenance manager. Preventive maintenance will be done based on the history provided on the maintenance log. The following parts are to be checked: consistently cleaning, lubricating, periodically service. The below cleaning regime could be used, which comes in the next slide. Here, cleaning procedures. The table shows the cleaning procedures that comes under the responsibility of the maintenance team. So the description for any cleaning procedures and parts have been discussed over here. The first one is the spool stand, which have been scheduled every day, and the mode of cleaning is through the cotton. The remark shows that ensure there is no pins, labels and buttons other than the thread cone on the spool, which means that it's need to be ensured by the maintenance officer that there is no pins, labels and buttons over the spool. The next description is for the machine head, which is the important part of every stitching machine. This also have been cleaning scheduled every day as an everyday activity. This also here also the mode of cleaning is a cotton. The remark shows that bobbin winding, knee lifter connecting area, backside of the machine are need to be cleaned as much that there will be no dust particles on the entire area of the discussed parts. The next description is of the hook shuttle, which is the part of the machine. It has been scheduled twice a week with a soft brush, and its remarks include the remove of the dust and threads, clean the feed dog, trimming mechanism, hook set areas, feed bar areas, etc. This all comes in the third category. The next description is about the oil tank. It is being observed that the oil leakage and spills are destroying the parts made by the workers, so it's a crucial factor as well. Where the flap and thread etc. will be accumulated with a brush tweeze or a magnet. Description for the bottom oil tank is scheduled once in a week as a cleaning procedure. This blower has been used in for checking there is no pin, bits, cloth and bits of threads, label etc. in oil tanks and edge of the oil tank.
As Lukman has just discussed cleaning procedures, now I will be discussing some checkpoints before working on a stitching machine. So one of the most important and basic checkpoint every operator has to follow every day is to see and check if the type of needle being issued is correct or not. Look for the correct size. Also, a worker must check the point of needle if it is suitable to the fabric or not. Thickness of needle should also be decided according to the type of fabric being used. Secondly, machine operator must check the thread being used before working. He must make sure if thread is suitable to the fabric and sizes of needle. Operator must check the correct orientation of thread stand. Thread cone should be kept vertically on the thread spool. Thread guide holes also have to be checked if they need to be replaced or not. Spring, needle thread tension, bobbin thread tension, looper timing, pressure foot feed dog, needle plate and pressure must also be checked before working by every operator. And here you can judge if you have successfully achieved the correct tension or not. This picture shows us the correct tension for the top thread, while this picture shows us needle bar, plunger pump, rotary hook and oil tank. We also have this labeled picture where we can identify needle, pressure foot, feed dog and bobbin case. Now from here onwards you'll be hearing P. Usama Arshad. He will be explaining you further about the case study.
Conclusion: cleaning procedures. However, the above mentioned tips are more useful to the sieving room personnel. Sieving mechanics can prevent the sieving defects by maintaining the care of the industrial sieving machines. Defect-free seam and stitches of garments are always having the value-added products that gain more profits. Seams quality must be obtained through the preventive maintenance of the industrial sieving machine respectively. Training of all operators on autonomous maintenance. The core idea of autonomous maintenance is to provide the operators with more responsibility and allow them to carry out preventive maintenance tasks. All workers in the production unit must be properly trained for the preventive maintenance to be effective. This should be made part of induction training program. This training is essential to avoid unnecessary breakdown of equipment. The operators should be taught autonomous maintenance to avoid downtime of machines. Maintenance is independent maintenance carried out by the operators of the machines rather than by the maintenance technicians. This is the core concept of TPM. The initial cleaning and inspection. The initial cleaning of the machines is essential for high quality maintenance. It includes the thorough cleaning of the equipment and its surroundings. The purpose is to ensure that the machine performance is fully restored by identifying and eliminating all signs of deterioration. The cleaning and inspection should be done by the operators so that they become familiar with the machine details and can see where dirt accumulates and how and what problems are occurring. Inspections that should be done on machines could include leak detection, checking of loosened bolts, lubrication inspection, correction of defective items, removal of material rest from oil or water, removal of dust and dirt and therefore reduction of a paint corrections. Eliminating contamination. After the initial cleaning has been performed and the equipment has been restored again, it is highly important to make sure that it does not deteriorate again. This happens by eliminating all possible contamination sources and improving accessibility for cleaning and maintenance. During cleaning, it will be vital to identify where the dirt that is removed is coming from. Is it being produced inside the machine or is it coming into the machine from outside? The sources of these contamination can then be removed or minimized. Maintenance manager should consider the following possible solutions. Maintain cleaning standards, achieving lasting cleanliness by avoiding soiling, promoting cleanliness, encouraging operators to keep order. Operators should be shown how to facilitate the planned inspections. Developing standards. Developing standards for cleaning, lubrication, and inspection. The establishment of standards for operations of cleaning, inspection, and lubrication follows the suggested lubrication and inspection schedule. This is the step which can be individually adjusted from the operators to every machine. Inspection and monitoring could involve the following: checking lubrication level, locating leaks, tightening loose bolts, identifying possible mechanical problems such as cracks, performing mechanical adjustments like tension measurement and regulating sensors. Finalizing standards. The last step for a successful implementation of autonomous maintenance is to finalize all provisional standards and establish a process for autonomous maintenance to be carried out by the operators in the workshop. Equipment monitoring and control. Top management of the company should be responsible for the coordination and monitoring of the maintenance activities. Continuous review of workflow will ensure that the management of the property is aligned with clients' expectations and vision. Staff at all levels will be managing and maintaining the property utilizing the standard checklists and workflows. Safety and occupational standards. It is essential to implement appropriate risk assessment procedures for maintenance operations as well as employing adequate preventive measures to ensure that the safety and health of workers involved in maintenance activities. After maintenance operations are complete, special checks like inspections and tests should be carried out to ensure that maintenance has been properly carried out and the new risks have not been created. During the whole process, good maintenance management should ensure that maintenance is coordinated, scheduled, and performed correctly as planned, and that the equipment or workplace is left in a safe condition for continued operation.
Bismillah ar-Rahman ar-Rahim. Conclusion. The aim of this paper is to help the local textile company to develop and implement effective maintenance procedure. The effective maintenance procedure of the organization was based upon unplanned maintenance, which means machine was fixed only if machine totally breakdowning. This is not effective for company because a lot of time in reacting this breakdowning. The system is now changed to preventive maintenance. The purpose of this maintenance is to escape from continuous breakdowning, disturbance, ensuring less downtime, and also increase the storage capacity. By introduce control system to order the spare part optimally, so that there is no downtime of machine due to unavailability of spare part. Thank you.